This is Euclid Book 11, proposition number 8. And it says as follows. If two straight lines be parallel, and one of them be at right angles to any plane, the remaining one will also be at right angles to the same plane. Okay. Now, how did we draw all of this? Well, I started by drawing straight line AB, and then I drew this perpendicular line BD. And then I drew a perpendicular to that at CD. Then I just made line DE equal in length to line AB. As soon as I did that, I connected all the other points, and there you go. Okay. Then, of course, I drew this parallelogram in the background to show that certain lines here were in the same plane. Let's just get into this, shall we? Let AB and CD be two parallel straight lines. Well, this line is parallel to this one. And let one of them, AB, be at right angles to the plane of reference. Well, AB, of course, is at right angles to BD, and BD is in the plane of reference. Okay. I say that the remaining one, CD, will also be at right angles to the same plane. So we're going to say since AB is at right angles to this plane, so is this. Okay. For let AB and CD meet the plane of reference at points B and D, and let BD be joined. Therefore, AB, CD, and BD are in one plane by Euclid Book 11, proposition number 7. Okay, they're not in the plane of reference, but they are in a different plane. If you were to draw a plane that covered this, and this, you would find that all three of these lines are in one plane, just not this one. Okay. Let DE be drawn in the plane of reference at right angles to BD. So that's what we did. We drew this. Oh, I'm sorry. We drew DE, and it's at right angles to BD. Okay, so far so good. Let DE be made equal to AB. Well, the length of this is equal to the length of this. Okay. Now, and let BE, AE, and AD be joined. Well, we did. BE, AE, and AD, they've all been joined. Very good. Now, since AB is at right angles to the plane of reference, therefore AB is also at right angles to all the straight lines which meet it and are in the plane of reference. And this is by Euclid Book 11, definition number 3. Therefore, each of the angles ABD, well, there's ABD right there. And the angle ABE, which is this one, and this one. Okay? ABD and ABE, those two angles that I just showed you, they're right angles. Okay. And since the straight line BD has fallen on the parallels AB and CD, hang in there, folks. Therefore, the angles ABD and CBD are equal to two right angles. Well, let's go to ABD. So, let's see, ABD, that's one of them. And CBD, okay, I think it's this one, CBD, something like that. Oh, CDB. Okay, so it's CDB. Okay, got it. That's by Euclid Book 1, proposition number 29. But the angle ABD is right, therefore the angle CDB is also right. So if ABD is right, then CDB is also right. Therefore CD is at right angles to BD. CD is at right angles to BD. And since AB is equal to DE and BD is the common, okay, since this here, as you can see here, is equal to DE, which is this one here. And BD is the common, which is this one right here. Then, let's see. The two sides AB and BD are equal to the two sides. Okay, so AB and BD are equal. That's these two. And they're equal to the two sides ED and DB. ED and DB. Okay, so we have this side equal to this side. We have this side equal to itself. And the angle ABD is equal to the angle EBD. So ABD, which is this angle right here, is equal to the angle EDB, which that would be this one. That angle right there. Okay. For each is right, therefore the base AD is equal to the base BE. Well, let's look at the base AD. Well, this is base AD. Okay. And the base BE. Well, where's the base BE? Well, that's this one right here. Okay. So basically, what you've got here is BDE, this triangle right here, is equal to triangle ABD. These two triangles are equal. Okay. And since AB is equal to DE and BE to AD, the two sides AB and BE are equal to the two sides ED and DA respectively, and AE is their common base. Therefore, the angle ABE, which is this one, this one, this one, this whole angle right here, is equal to the angle EDA. Well, let's see where EDA is. EDA, that would be this one. So those angles are equal. But the angle ABE is right. Therefore, the angle EDA is also right. Therefore, ED is at right angles to AD. Well, therefore, ED is at right angles to AD. But it is also at right angles to DB. Therefore, ED is also at right angles to the plane through BD and DA, which is by Euclid Book 11, proposition number 4. Therefore, ED will also make right angles with all the straight lines which meet it are in the plane through BD and DA. But DC is in the plane through BD, DA, inasmuch as AB and BD are in the plane through BD and DA. Yada, yada, yada. And this is by Euclid Book 11, proposition number, looks like proposition number 2. Is that what that said? Yep. Okay. Euclid Book 11, proposition number 2 is the reason. And DC is also in the plane in which AB and BD are. Therefore, ED is at right angles to DC, so that CD is also at right angles to DE. Whew. And I think you're starting to follow all this. But CD is also at right angles to BD. Therefore, CD is set up at right angles to two straight lines, DE and DB, which cut one another from the point of section at D, so that CD is also at right angles to the plane through DE and DB, which is by Euclid Book 11, proposition number 4. But the plane through DE and DB is the plane of reference, therefore CD is at right angles to the plane of reference, therefore. Okay. Did you get all that? If you don't, just kind of keep going over the video. These Euclid proofs are actually on the internet, so you can just kind of read them for yourself. Alright. I will tell you more in a future video. I'd like for you to stay tuned.